I don't want to jinx it, but it never works on the first time. I'm trying to project something right here. So this is impressive. We'll have a spectacular fail later in the presentation now, I'm sure. Good morning. Welcome to the morning of day 2, which is normally the most hungover and tired of the talks of any conference. So I thank you very much for showing up here. I'm going to talk today on kind of practical lessons learned out of this shift into DevOps and cloud. So I'll give you a brief background on myself. Started out in offense and pen testing. So if you know NCC Group, or before that ISEC Partners, or before that was at Stake. Started out there doing a bunch of fun pen testing and security research, and then went in-house over to Etsy. For those that don't know, so it was, at the time, it was Netflix on the west coast of the US and Etsy on the east coast of the US that were pioneering what we now call DevOps and cloud. So that was an extremely interesting CISO role to take at the time, because there was nothing, there was no material out there. We were kind of just figuring it out as we went. And then from that, from the lessons learned out of there about how do we actually start to defend our web applications, our APIs, our microservices. We had a bunch of lessons learned out of that. We actually turned those into a product and left Etsy, co-founded a company called Signal Sciences, which we now make what the marketing folks would call a next-gen WAF or a RASP product that you can drop in to defend your web applications, APIs, microservices. This talk is not about that bit. No one needs to hear from yet another vendor. But if you are interested in any of that, you can take a look at our site. You can chat with me afterwards. I'm more than happy to talk about it. Cool. All right. So what is this talk actually about? This is the talk I wish I could have given myself on day 1 of starting a CISO role in a what was at the time, but not called it, a DevOps shop. I went through so many painful lessons learned of trying to adapt the way that we've done kind of security for waterfall environments, so adapting an SDLC and everything like that, that I hope you get to learn from my pain in this talk today. So my goal here is to kind of share how we've done things and then how we adapt those specific controls. And I'm going to give you the conclusion right up front, which is that security shifts from being this gatekeeper to its number 1 focus becomes enabling security teams to be, or enabling teams to be secure by default. That's the fun. It's this existential shift that we're going through right now, and that's kind of the theme of the talk today, which I don't think will be that different from anything that you've heard throughout this conference, right? That we're really, whether we're calling it shifting left or going from a gatekeeper to an enabler or whatever, it's about security changing to enable the business rather than function as a gatekeeper. So what has changed? I don't need to spend a lot of time on background, but I think that a couple of these things are interesting, which is that first, change now happens. It's not just kind of like a linear progression of change. It's exponential. Change now happens orders of magnitude faster than it used to. So this was super apparent for me on day 1 of that switch into the role at Etsy, because my last day as a pen tester and as a consultant, I was at a large US healthcare company, and they deployed to production once every 18 months. And I left there on a Friday, and I started at Etsy on a Monday, because I'm an idiot and I took no time off and just went through the weekend. Started Monday morning, and the leadership at Etsy sat me down Monday morning and said, we deployed to production 20 times a day. Figure out security. Go. So I ran to the nearest whiskey bottle as fast as possible and downed as much of that as possible. And then figured, all right, well, let's start getting to work and start figuring this out. And by the time I left, I mean, they were doing 50 to 100 deploys a day, I think. Somewhere up there now, too. But the change here is really that it goes from on the order of every few months or every few years down to maybe in your organization it's every month now, or every week, or every day, or every hour, or every few minutes eventually. But the point is that it's only getting faster, regardless of our organization. And because of that, there were many injection points in the process for security, and now there are very few. And it changes the way in which we do that. And so the other side is that there's kind of this decentralized ownership of deployment, where code used to be written by one group, shipped to another group, shipped to a different group, shipped back to that group for fixes, shipped off to a different group to deploy, and kind of in every case it was thrown over the wall to be somebody else's problem. And by the time code made it to production, it was nobody's problem and everybody's problem all at once, which is not the situation that anybody really wins out of. So what happens is when in this kind of DevOps environment where developers can deploy directly to production by themselves, it doesn't mean that these other functions go away. We don't stop testing code, we don't stop looking at code for performance, and we don't stop thinking about security, but it changes the way in which we do it. And so there's kind of two changes that are necessary. One are the technical controls, so the different pieces of the SDLC that have to change, and that's what this talk is about. And then the other side of it is how do we change the culture of the interaction with security teams with the rest of the organization? That's what that talk that's linked there is. I can just send you the PDF. There's a more up-to-date version of that if you just want to email me. But I think the number one theme, like if there is one lesson that I hope you take away from this talk, forgetting all the technical stuff, it is that security can no longer be outsourced to. It's that security's number one role focuses to making the rest of the engineering organization security self-sufficient. This is the number one lesson of the change that we're going through. And because of that, it can only be successful if we can bake into the development and the DevOps process. We are at this inflection point with security right now in the way that IT procurement teams were at the start of the rise of cloud, which is that when the business wants to ship a new feature or a new product or spin up new infrastructure, and they say, okay, we want this, and the IT procurement teams would say, okay, well, it's going to take 18 months for us to review and build out servers for and everything like that. The rest of the business would just say, cool, that's great, you can go do that. We're going to go put a credit card down and be up in Amazon in 20 minutes. So you go figure your own stuff out. We're going to be in production. We are at the same spot with security right now, which is that if we say, oh, that's great that you're going to ship that new feature, we need 6 months to review it, the rest of the business isn't going to stop, right? And so their answer is going to be one of two things. It's either going to be, that's great, you can have 6 months to review it, but we're going to be in production starting in 20 minutes. So you can take as long as you want because it's already going to be live. And what happens then as part of that is then they just stop talking to the security team. And so we are at this, I think what's both a challenge and exciting at the same time is that we are at this major inflection point to change the way that we've done security for the last 15, 20 years. And if we do it right, and this is kind of my point later in the talk, I'm stealing my own thunder, but if we do it right, we can actually make ourselves more secure than when we started, right? That's really a lesson that I came out of this really deeply believing. So, all right, let's start with a highly technical flowchart of how, if we don't try to adapt the SDLC or any of our AppSec practices, how does that look in a modern world? So you notice in the technical flowchart, the safety and security train plows into the DevOps car, and nobody is happy after that. This is probably one of my favorite security memes ever because it perfectly exemplifies the security industry of shouting about safety while then causing train wrecks themselves. So enjoy that. That's the most technical image in the deck, so don't worry. It only gets better from there. If you think that joke is bad, that was the best one. So they only get worse all day, so get ready. Okay, so the common pieces of an SDLC, and this is really what we all have kind of pieces of this. Like if you step back and look at organizations across entire industries, this is what it tends to kind of look like. There's training, threat modeling, static analysis, scanning, stuff like that. Which of these need to adapt the most? Well, this is what I'm going to be talking about today is the ones that are bolded here. So static analysis, dynamic scanning, visibility, feedback, etc. The important point is just because I'm not discussing the other ones of training and design reviews and threat modeling and all that, it doesn't mean we stop doing them. This is just because we had other great talks on those during this conference, and just as a function of time, there's not enough time to cover all of these, so I'm just going to focus in on these particular ones. All right, let's start with static analysis. So when I asked a private group of CISOs that had used some kind of legacy static analysis tools in the past and asked what was the biggest report they had ever seen when they first turned on static analysis, the record is now 13,000 pages, which is incredible, but also not shocking at the same time. All right, how have we done this in the past, right? When you think of kind of a legacy static analysis, It's typically been done as a really heavyweight process. Right? So what we would do is we'd go get these like really heavyweight commercial static analysis tools, we'd turn them on, and we'd run them once a month or once a week, like on a build server or something like that. And we'd get this huge volume of output, 99% of which was false positives. Right? And so then we'd spend a bunch of time trying to tune it and adjust and find, excuse me, what rules are effective. And that tuning process would last months to years. Because we'd start kind of top down. We'd search for everything, and we'd try to slowly refine it over time. The funny thing is, this was kind of acceptable-ish in a waterfall world, because think about it. If you're releasing software every 18 months, and it takes you 24 months to tune your static analysis, okay, well, you've missed like 1.5 release cycles, basically. So it was acceptable-ish. Okay, so how do we actually adapt this control? So a modern focus on static analysis is really thinking about, I'm going to give you the methodology here, and then I'm going to give you a couple examples, and then a few examples of how we can actually use static analysis in totally different ways to get some really interesting results. So first, the methodology. It's that we shift from this top-down model looking for everything to a bottoms-up model looking for very specific things at first, and then widening what we look for over time. So we might say, okay, I just want to start by looking for one specific class of vulnerabilities. And then say, all right, and I just want to look, kind of shallow for those. Now I want to add a second class, now I want to add a third class, and now I want to go deeper for each of those. This enables, the focus here is on enabling the velocity that's needed for DevOps. Right? This is huge. It's the blend of culture and technology that actually makes security projects successful, which is that, especially when you're dealing with a control that super historically was viewed by developers as both full of false positives and super slow, you need to demonstrate that this control still has value in the DevOps world and can be made to adjust to that. So you want to ultimately get to the point where you can run static analysis on every code commit. You want to be feeding that back to the developers. So an example of that would be, rather than trying to start for all of these different web app vulnerability classes, start for, pick one. Pick something like command. I like command execution as a good starting point, because no matter what your technology stack, there's really only a half dozen ways in which you can introduce it. So it's a great way to get started really quickly on that, and then start to build up to more complex ones of SQL injection, cross-site scripting, stuff like that, directory traversal. But again, the focus is not only on findings. You accept, and this seems counterintuitive at first, especially as security people, but you take the false negative hit at first, you recognize that there's going to be issues that you missed, to optimize for false positives and speed. And by optimization there, I mean you want 0 false positives, and you want to show that it can run as fast as possible. And then you accept that you're missing some things, and you increase the depth of the scans over time. Okay. The first of 2 ways that we can actually change static analysis as well, in addition to that, to use certain, to have certain interesting ways that you can get effective coverage out of it. So the first is identifying when certain types of code show up in the code base that should drive conversations. So in this case, I mean like hashing, encryption, file system operations, things that are rare and fairly sensitive. And so the old approach to this is kind of the policy approach that says, okay, we ban MD5 from the code base. So if MD5 ever shows up, it blocks the commit and tells the developer to use SHA-256 or something like that, right? Now, we don't stop doing that. That is totally a correct thing to do, right? You don't want to be using MD5 or weak hashing functions. But what you're actually missing if you just do that is this tremendous opportunity to raise a flag at that point to drive a conversation. Because it's not, what hashing function a development team uses is not what keeps me up at night. It's why are they using that in the first place? If they're using hashing, it means there's something in that functionality that they're writing that they think is sensitive. Is it functionality that I know about as a security team? Is this coming out of nowhere to me? Is it totally a new set of user data? What's going on? You get this incredibly strong signal that you should go have a conversation at this point. And that might be from the security team, it might be for an architect, it might be for a DevOps lead, whoever, but this raises a really nice flag that says someone senior who really understands what's going on should go have a conversation with this team. When we first started doing this sort of stuff at Etsy, I thought it would be marginally effective at best. It turned out to save us several times. I was deeply shocked at how useful this actually was. Because there were times where we saw teams introduce hashing, and we'd go talk to them and we'd say, hey, we noticed you're doing that. Like, what are you trying to protect? And they'd say, oh, well, we're actually going to be collecting this whole new set of user data, but we know it's going to be sensitive, so we want to protect it, so we're going to hash it. And you look at it and you're like, oh, okay, actually, no, you need to be encrypting this, not hashing this. This actually, and you can talk with the team and say, okay, well, actually, we've written a whole encryption service for you that all you need to do is call this internal API, and we can handle all of this for you. And then it can be a win-win for the teams where it's easier for them, and you've just mitigated a whole class of vulnerabilities that you had no idea about. Plus, it's a great feedback loop into the rest of your process that says, how did something get to this point without the security team knowing about it or without it bubbling up to somebody else? So that's one of the tips. And the second and final tip for static analysis is kind of adapting the way that we think about sensitive parts of the code base. So for every application, for every microservice, for whatever, there's always some sensitive part of the overall application or a particular service. That might be the role-based access control. It might be the session management. It might be some sort of, there's always these things that are written at the very beginning of the app by kind of like a senior architect and then never updated because it's a core part of the framework. So what you want to know from a security side or a development lead side is, if these are things that I never expect to change, that is fantastic because there is no better set of security alerts than if they actually do change. Now, in the old model, like in kind of a waterfall blocking model, what you would do is you would say, okay, if any of these parts of the code base change, it's blocked from being committed until these 3 people sign off on it. Right? That's kind of the old model. The problem, if you try to do that as you're going through a shift to DevOps, is that the first time that there's an outage or there's some sort of incident that's related to this part of the code base, and a senior SRE like engineer or a senior developer, or someone who is working an outage at 3 a.m. Has to change that part of the code base, and they get blocked by a security check that says, no, you need to have sign off before you can change this. At 8 a.m. the next day, you're going to have a very bad day, and every security control is getting ripped out of that code base, and you're going to have to fight for every one of them to go back in. So the way that you mitigate this, where you keep a control and an alerting framework in place, but without introducing friction, where you can still enable velocity, is you say, okay, if any of these sensitive parts of the code base are changed, when someone tries to commit code there, via your source control, you send a message back that says, if you change, this is a sensitive part of the code base. If you change it, it is going to page these 5 people. And that might be your CTO and your CISO and your chief architect and all of these other senior people. And so what it allows for is, if there's a brand new junior developer who's accidentally modifying the wrong part of the code base, they're like, oh, no, like back that out real quick. Do not page the CTO with my name on it. But if it's a senior engineer who's working an outage or an incident and they need to change it, they can say, yeah, no problem, page them. They're all in the room anyway. We're working on this incident. And so this I think really perfectly exemplifies the changes that we have to make from blocking style controls that need sign off and all of that to ones that still enable velocity but don't sacrifice that coverage. So this is how I would encourage you to kind of have a framework of thinking about adapting controls that we have. So, all right, that's it for static analysis. We're going on to dynamic scanning. This meme has no relation to dynamic scanning. If you can find a better meme for dynamic scanning, you are a better speaker than I am. So please send that over to me. I spent an embarrassingly long time trying to find a meme for dynamic scanning, and this is the best I've got. All right, so this section is actually much shorter, which is that dynamic scanning, and by that I mean like app scan and stuff like that, right? The scanners where you would point it at your application, it would try to crawl it and discover vulnerabilities. It used to be kind of just a baseline thing that said, oh, if a scanner can find it, we should probably fix it. You'd occasionally see organizations kind of misuse it as a substitute for pen testing, even though it wasn't. So how do we adapt this control? Really, I think what we do out of this is we put much less of an emphasis on it. We don't rip it out entirely, but if we can kind of build it into our CI pipeline to run some scanners against it, great. But I think the biggest lessons learned on this is that it's very easy to go down this giant time sink to try to get scanners to really work effectively against your applications and your APIs and everything there. And I can tell you from personal experience and from talking to a lot of other CISOs, in the general case, that's wasted effort. So the problem is that scanners were built for kind of early 2000s web application architectures, when web apps were very linear, right? When they went from page 1 to page 2 to page 3 to checkout to whatever. And so it was the scanners could kind of figure that out and crawl the apps and everything like that. If you look at a modern application, it's half the logic is in JavaScript. It's single page applications, right? It's all of this operational complexity there from the application side, and the scanners have no idea how to figure that out. So it's not that they have no value. It's not that they that you rip them out or anything. It's that we all have too many other important things to do to go spend 12 months on trying to get a scanner to crawl an app effectively. Just kind of baseline it, throw it out there, and move on to your next project. But there are two kind of cheap and easy way, cheap in the time sense, of ways to adapt scanners that can actually be really effective. So one is ensuring that your security policies are actually being enforced. This is one that doesn't really make sense on a whiteboard, but if you've ever worked in production web operations, you know how everyone's view of production and what is actually in production are often two very different things. So this is where scanners can actually be really effective, is to say, okay, we've put out a security policy that says the entire app needs to be served over TLS or SSL. Okay, great. Well, what happens is there's always edge cases where that falls apart. So you can point a scanner at your web app and say, I just want you to crawl continuously, stay within this domain, and alert me if you ever see a link that's HTTP only, right? Just HTTP, not HTTPS. Great. Those can just run continuously as part of your CI pipeline. Doesn't take any training from your side. Really cheap, really effective. Same thing to see if any of your security policies are also not being met, so not just your transport layer security, but things like X-frame options and these other HTTP header level defenses. Crawl the app continuously, alert if you ever see a response that doesn't contain one of these controls. And then finally, it's an extra control on ensuring that previous vulnerabilities don't return back into the code base and regress back in. So let's say you had we'll just make up a really straightforward example, like a cross-site scripting in the search box of your web app. Okay, great. So you had that vulnerability, it gets fixed in the code, and now you move on. Well, typically you add a unit test or something there to make sure it doesn't show back up. Well, the problem with scanners is it's hard for them to crawl the apps, but if you can tell them exactly where a vulnerability did exist, they can go try that every time. And so what you can do is use your scanners to say, I had a cross-site scripting here, or I had a SQL injection here, and I want you to try to exploit that once an hour, and alert me if it's ever successful. Because that means that that vulnerability has gotten reintroduced back into the code base, and this is it gives you 2 for 1, because it tells you that vulnerability is back, and it also tells you that something is wrong with your unit testing and all the other controls that you have in place there too. So again, really cheap, really effective. All right, moving on to security visibility. This is a sarcastic Twitter feed for operations folks. It's, it's painfully accurate. We'll just say that. Okay, so security visibility, how we've had it in the past. We've had logs, we've had customer service reports, we've had outages. This is a very fancy way of saying we haven't had security visibility, right? All of these things were completely siloed sets of data. So how do we actually adapt this control? This is interesting because right now what we have to do on the security side, and this is actually a much larger point than just this section, is that we don't need to go reinvent the wheel. Right? I think a lot of security folks are looking at this shift and thinking like, we have to radically change everything. The answer is we don't. A lot of times we can learn the lessons that the development teams and the operations teams had to go through in the early shift to DevOps. And so security visibility is in exactly the same spot. They had to learn exactly the same lesson around visibility on the development side and the operations side, because by bringing those two, those were both siloed bits of data. By bringing those two together, it's what allowed the DevOps movement to happen, because it allowed everyone to have the context they needed to be able to move quicker. Right? By giving developers operational metrics, they could safely deploy to production because they could tell the servers weren't on fire as soon as they did. So you could combine that information and give context. Security is just starting to learn the same thing. So I'll give you an example, which is what's fascinating. So take just HTTP 500 errors, just generic errors in an application or an API or anything like that. What's fascinating is if you ask different parts of the organization what this graph implies, you will get completely different answers, which is really interesting to me anyway. I'm a giant nerd, though, so who knows. But if you ask your development team what this means, it might be, oh, yeah, we had a new developer who's just onboarding. they had their first deploy to production, it broke, and then we rolled it back, and the errors went away. If you ask your DevOps teams what this is, they're like, there's probably that one development team who's breaking things all the time. Like, this is the third time I've been paged this week because of it. If you ask your security team what that is, they say, oh, that's interesting. 500 errors, like, that might be somebody discovering a vulnerability and trying to figure out a working exploit payload before they get it to work. And if you're ever fortunate enough to ask your attackers and your adversaries, you will often hear, oh yeah, that was me discovering a real vulnerability and getting a working exploit going on that. So what's missing here is context. And this is where we start to bring, this is how we think about enabling the shift to DevOps in a safe manner, is bringing development relevant data, operationally relevant data, and security relevant data together in a way where everyone can consume it. Because now, any one of those groups can look at these graphs and say, wait a minute, why did that spike in errors that we thought was something else happen at the same time as a spike in attacks? That is really interesting. Let's figure out what's going on. So that's really the takeaway out of this, is how we enable this transition safely is by bringing this sort of visibility and breaking down those silos. I think I've now said breaking down silos 4 times in a talk, which officially qualifies me as a manager or something. It could not be more cliche, but it's actually true. All right, so moving on to feedback. And Office Space, this movie is now 19 years old, which A, makes me feel super old, and B, qualifies it as a vintage meme, so I'm allowed to put it in slide decks again, just like it's the early 2000s. So that's exciting, at least. How we've had feedback. We've typically had feedback as annual pen tests. How many folks have gone through either delivered pen tests or had pen tests done to their applications or anything like that? Yeah? Cool. So we've typically done pen tests as, once a year, you have 1 or 2 consultants come in for 1 or 2 weeks and run a pen test. The problem is, it really only answers the questions, do I have bugs? And the answer is yes. It's always yes. I say this as a former pen tester who spent a long time doing this. But just like with kind of legacy static analysis, when applications were only released every 6 months or 12 months or 18 months, it was kind of real time enough. You could kind of point them at like the new thing and that was enough. So how do we adapt this control? This is where the combination of bug bounties and pen tests, I think, it gets really exciting. I don't think one replaces the other, actually. I think that they complement each other really well. And I've been on all sides of these, of running bounties, running pen tests, being a pen tester, being a bounty researcher. Because the problem with pen tests is you were stuck because you always had to either tell your pen testers to go very broad but very shallow, or to go very deep and very focused in just one spot. And so each of these, if you use them in combination, can really play to their strengths, where bounties can go very broad and somewhat deep, and pen tests you can then free up to use for very, very focused and specific things. And so they really complement each other, and actually it's one of those where 1 + 1 = 3, because you combine these 2 things together and you get an even stronger benefit out of that. So yeah, again, I really believe in these. When we went through the bounty program that we had ourselves, this was long before any of the services existed to help you out with it. So it was, to put it mildly, it was a complete nightmare for the first several weeks. But the good news is now there are a bunch of services that help you with bounties, that kind of work with the researchers and everything there, and that eliminates the huge challenge that those of us that did these really early on had to deal with, which all the problem was in logistics. If you want to catch me afterwards in the hall or anything, I've actually got a couple stories that won't go on camera about bug bounties that are very fun, we'll say. All right. Lots of security researchers or speakers take themselves very seriously and want to wrap up with a thought leadership section. I am not one of those, so I will leave you with the thought leader Hosen section. If you thought that joke was bad, it went nowhere in Germany, by the way. That was just not funny at all in Germany. I'll hope it's a translation thing. We'll see. All right. So these are a couple thoughts on, I'm really fortunate that I get to talk to a lot of CISOs in my current role. And this is kind of a few thoughts on what I see as being the most effective across industries, across locations of organizations that are making the shift to DevOps and cloud successfully. Like, what's the commonality amongst them? The biggest hallmark of it is really the combination of continuous feedback and continuous visibility. It's taking those principles of visibility, bringing those not just to your security team, but to your application teams and your DevOps teams, and then having feedback mechanisms in place so that you can be continuously testing what's going on. The other way to think about this is to really flip this around, and this is something we need to do much more of on the defensive side of security, which is to think like our attackers. And so at the end of the day, we really need to be able, if we want to be successful against real attackers, we have to be able to answer the question, how do I know when my attackers are being successful? The first time you ask yourself that question, well, the very first time you ask yourself that question, your answer is, we know, it'll be fine. Then the second time you ask yourself that question, it's, actually, if they did that, how would we find out about it? And if they did that, how would we find out about it? And you start to go down this whole train of thought of realizing, okay, for that type of attack, we would have no idea. For that type of attack, we'd have no idea, and onward and onward. And that's fantastic because it starts to frame your thinking about where do I invest my time and my resources? Because I want to be mitigating real attacks, not just ticking compliance checkboxes along the way. So, when I first started in my role at Etsy, to be totally honest, when they sat me down and said, we deploy to production 20 times a day, we're kind of creating this whole DevOps thing, I'm like, okay, this is insane, right? Like, this is going to make us so much less secure. This is absolutely terrifying from a security perspective. And what I actually learned going through it is it's actually the opposite. If we embrace the shift to cloud and the shift to DevOps, and we do it right, and that's a big caveat, but if we do it right, it can actually make us more secure. Because there's kind of three reasons for that I'll go into. One is it gives you this greenfield opportunity as you're changing the systems that you have to think about how do we detect our attackers as early as possible in the attack chain. So we want to, right now, so many of us get notified about a breach because a major newspaper, the Wall Street Journal or something, is calling to ask for comment as to why our database is up on Pastebin or something like that. That's not how we want to get notified about breaches. We want to do a better job than that. So we start to think about, okay, if an attacker is exfiltrating our data, how would we know about that? If an attacker is laterally moving across our network, how would we know about that? If they're doing initial vulnerability discovery and initial exploitation, how would we know about that? And because your systems are now changing more frequently than they did in the kind of data center waterfall world, it gives us an opportunity to think about that and start putting some new and effective controls in place. The second is it gives you the ability to continuously test and refine your vulnerability triage and response. What I mean by that is the first time that a vulnerability comes in for some crazy part of the code base that you've never seen before or an app that you've never even heard of that it turns out your company built 8 years ago and that entire development team is left, which happens all the time, there's no idea what to do, right? Like you get this vulnerability report and it's like, oh, wait, that's our application? Like what? Okay, who do I talk to? And the thing is, you want to be running these sort of exercises as frequently as possible because the first time that conversation happens, it's really painful. Everyone is trying to figure out, okay, who's responsible for this thing? No, the last developer that worked on this left 8 years ago, so like, who should even own this code? You don't want that conversation to be happening while someone's actually exploiting that vulnerability or just got reported externally and you're panicking figuring out how to try to solve these sort of things. And that kind of ties into the third and final point on that, which is it allows you the ability to continuously test and refine your security operations, data forensics, incident response, SecOps, anything. It allows you to test these processes. What you want to do is treat vulnerabilities that come in, whether it's a bug bounty report, whether it's a pen test report, whether it's a vulnerability that you discovered internally, treat it as if it had been a hostile attacker. And say, what would have happened if this was a hostile attacker finding and exploiting this bug? And you start to ask yourself questions like, okay, did they find any other bugs? And even if they reported this very benignly and very nicely, did somebody else find this 6 months ago and has been exploiting it? And again, the first time that you ask yourself these questions, you will not like the answers. Because the answers for almost every organization are, we have no idea. And that's great, because that gives you the starting point. That tells you, okay, if we want to be able to answer these questions, here are the 5 things that we need to go invest in and really do. So a lot of security is doom and gloom. I want to leave you with a actually upbeat, happy story here, which is that this was from a bug bounty researcher, security researcher, who discovered a vulnerability in Etsy, and they actually wrote up the whole thing that they went through from their side and published it up on this Reddit thread there. And I think it's still still up and live. But what was really interesting is, and really fun from our side, was that they discovered this vulnerability, and they were working on their exploit payload. And then they went to go confirm the exploit payload again, and it stopped working. And they were like, huh, that's weird. And they wrote into us, and they were like, hey, so I noticed this exploit that I had isn't working anymore. I can't imagine that's a coincidence. By the way, I was testing from my home IP, and I promised I was going to report this, and please don't sue me, and we're okay here, right? And we wrote back, and we're like, yeah, it's totally fine. We actually detected you doing these attacks. We detected you when you discovered this vulnerability, and we were able to ship a fix before the attacker even reported the issue to us. And this is not a story of, wow, Etsy was so great. This is actually a story of, this is why I firmly believe the shift to DevOps can actually make us safer, is that this is kind of the moment that I realized the underlying truth of all of this, which is that every development methodology has vulnerabilities in it. Every one of them, it has. But DevOps, shifting to DevOps, shifting to cloud, be able to move quicker, it means for the first time, we can actually move faster than our attackers. If you think about, if this issue had come in a waterfall world, and we needed to rush an emergency patch on an 18-month release cycle, like, okay, maybe we could get something out the door in 3 months or 6 months, but other than that, we were in trouble, we'll say. But if you're shifting to this DevOps model and you need to do an emergency patch and you're already deploying once a day, well, it's just part of that day's deploy. The emergency patch just goes out the door just like any other software there. So this is why it can actually make us safer, is we're always going to have vulnerabilities. DevOps actually gives you the ability to react. So in conclusion, I think modern application security and how we survive the jump to DevOps and cloud is by shifting from a focus on trying to exclusively eliminate bugs before they go to production, which is an impossible goal. We don't stop doing that, but we have to realize it's an impossible goal. It's software development. There's always going to be bugs. What we need to shift to and build on top of with that is to say, we need to focus on how do we give visibility and feedback to the engineering teams directly so that ultimately they can become security self-sufficient. So thank you for sticking through my talk in the morning. You're all awesome. Cool. I think we got time for questions, right? Or am I way over? I don't know if that's the right clock. Questions, please. Mm-hmm.
So imagine you're a company that, or you're new, you're new somewhere, and you are joining the application security team of a place where they're clumsily doing DevOps, and you want to dive in. What would the first thing be that you would want to do?
Yeah, great question. What I would have done and what I've done in the past, and I would have messed it up at first, is to try to jump into technical controls, which is totally the wrong thing. The actual answer there of how you be successful strategically is you go focus on building a relationship with the rest of the organization to say, listen, I understand that you are changing the way that you are building and delivering software, and my role is to adapt security to that. Like, if you don't get that understanding where everyone is on the same page, that security is going to try to adapt as well, none of the technical stuff you're going to put in place is going to matter, because everyone's just going to try to ignore the security team. And so you have to focus on building that. And what you do is you have a very honest conversation, and you say, look, just like as you're going through the shift to DevOps, it's not going, it's not going to be clean every time for you. Like, you'll have hiccups and things will break. It's going to be the same from the security side. We're going to try a lot of things. Some of them aren't going to work, and we're going to adapt. But I want you to understand that our intention is that security is here to enable that shift. If you can get that buy-in, then the technical stuff is the easy bit. It's still an incredibly hard problem, but comparatively, it's the easy bit. Yeah. Other questions, please. Yeah.
Actually, I have a question, if you don't mind. So what was one of the most interesting things for you switching from a pen testing role to actually a defender role, if you look back?
I had one of the funniest moments in my career with that, actually, which is I was the one who had done the pen test for Etsy. So I had written their big pen test report with all of, thinking I'm this great pen tester, and I'm like, oh, I've got all these sweet findings and vulnerabilities and all that. And I start on day one, and my new boss says, hey, we've got this pen test report from this idiot. It's your problem now. And he handed me back my own pen test report. I'm like, oh. And like, well, that one doesn't really matter. And yeah, that was one of the more interesting jumps for sure. I think the challenge going from pen testing to an in-house security role is it's really tempting to get lost in the details. Right? It's really tempting to say, this vulnerability matters, this vulnerability matters, that vulnerability matters. Individual bugs on a strategic scale don't matter. Vulnerability classes matter. And the ability to detect and respond matters, right? Jumping up from that kind of tactical view to that strategic view, I think is the big jump you have to make going from an offensive role in general to a defensive role in general.
Awesome, thanks.
Thank you. Yeah.
Can you suggest that the security bug should be tracked with the other bugs or not?
Oh yeah, definitely. So should security bugs be tracked as general software bugs like in Jira or some sort of ticketing system?
But there's a concern from some management that the security bugs should track separately.
Yeah, so what you do out of that, what I've seen be the most effective is if you're worried about the security contents of those bugs, there's actually two things that you can do there. Actually, it's another perfect example of the static analysis one that I gave, which is there's the blocking approach you can do, which is security bugs in a totally isolated system that no one has access to except the security folks. Or what you can do is you can put them in the main system and maybe restrict access a bit. But then what you do is you actually go instrument your bug tracking system, because that is one of the best targets as an attacker. Let me tell you, like if I'm an adversary going against someone's organization, the first two places I look are their internal wiki and their bug tracking system, right? But what's fascinating is the way that your attackers interact with those two systems is very different from your developers. Hi, camera. I will keep things kind of vague here, but what you can do is you can start to instrument those systems to say, I want alerts in place if people start looking at these sort of bugs in a anomalous way. I'm happy to give you a bunch of details on that follow-up afterwards. Because there are some interesting tricks you can do. But that's the way to think about it, right? You shift from this blocking mentality to an alerting mentality, because now you can detect. And detection, I will take detection any day over prevention, actually. Because prevention, I have no idea when it's failing. That's the fatal flaw of our first 20 years of security, is that we focused on prevention, and we never thought about how do we detect when the prevention fails. And that's why we all have a job today, I guess, so yay. Yeah, please.
Hi. I need to know if really DevOps help in insider threats, because I think everyone knows everything here. Development, operation, and security, they know everything. Mm-hmm. And especially when you have third-party vendors like managed service, they should know most of the thing as well. Thank you.
Yeah, so is the question how to kind of...
insider threats, so...
Yeah, insider threat, yeah. Totally, builds perfectly off of that sort of question. What I'd recommend for insider threat is really taking that previous question and applying it across all of your internal systems. So not just your bug tracking or your wiki. Think about, I didn't have it in this talk, I actually have it on another talk that I've got up online called Attack-Driven Defense. And it's where you start to think about how do adversaries actually operate against your environment. So, because insider threat actually becomes a subset of your adversaries, right? The way in which an insider threat goes and operates and achieves their objective, it's very different. It's the same systems, but it's very different than how your legitimate users do it, right? When a developer downloads the entire source tree, well, they download it on their first day. They don't download it on their last day. Or if they do, you've got an interesting insider threat walking out the door. When they go issue a refund through a customer service portal, they probably do 5 of those a day as part of their job. If they just did 500, something interesting is going on. So you start to think about, okay, for certain attacker types, how do they achieve the objectives against your system? And then think about how do we put alerting in place for those sort of, if these are the 5 signals of somebody operating as an insider threat this way, how can I get visibility across those and alerting out to the security team? And then what you do is those alerting systems, those not everybody has access to, right? Because no one else needs access to that. So you think about it as an alerting problem there, and you make it kind of a bigger scope than just the source control problem. But yeah, insider threat's an incredibly real thing. But what I would encourage you to do there also is couple it up with, it's not just insider threat, it's how we actually get attacked is that someone's going to, the way we all get compromised now is someone fishes an endpoint or they pop one of your web apps or your APIs, right? All the risk is shifted from infrastructure out to the endpoint and up to the app. And so insider threat, you can actually build something around from your endpoint of what does a hostile internal user look like? Well, actually it looks a lot like someone who's compromised one of your employees and is operating with their credentials in the first place. So, long answer to a short question, I'm sorry. Yeah.
Okay. Apart from the static and the dynamic analysis.
Sorry.
Apart from the static and the dynamic analysis, we just talk about the manual source code reviews. Manual source code reviews.
Oh, manual source code reviews?
So how effective is it? Like, I mean, does it add on like?
Oh, how effective are manual code reviews? Oh, I'm going to give the single most infuriating speaker response ever. It depends. Because it totally depends. What you want is a code review culture that's going on, so it's not just code review for security, it's code review as part of shipping code to production as well, right? And so code reviews, what I would encourage you to think about is both make them general as part of your engineering, just like have other engineers review other engineers' code, because more eyeballs on there is better, but then from the security side, you make it targeted, right? And it's kind of, oh, this new hashing function is showing up in the code base. Yeah, that should drive a discussion, but it can also drive a code review as part of that, right? How do we make these things targeted? So I think I've used up my time on stage. What we'll do is, I think we have another talk coming up right now, but then after that, I'll just be right around over here. So for any other questions, I'll be here. Thank you so much.